In this video, we are going to continue our study on data collection. In particular, we are looking at our objectives pertaining to sampling method. Please remember that in video 1, we already examined the differences between population and sample. We identified good sampling methods. In this video, we will continue with the bad sampling methods and sources of bias. So skipping clear ahead. Okay, so here we go. Here are some bad sampling methods to avoid. As we mentioned in the first video, you should pause the video now, read through all this, because we're not going to read it to you. Basically, a voluntary response sample is one in which people have to volunteer to participate. One of the classic types of things you encounter are like telemarketers who ask you for questions. Another one is an internet poll. The only way that people will fill out a survey on the internet is if they choose to fill it out. They have to volunteer. So why is this bad then? Why is it bad to only use people who want to participate? Well, frankly, if people want to participate, they usually have really strong opinions. For instance, if you were going to ask people, will you tell us your opinion of President Obama? A lot of people who have a very strong opinion, they may say, oh, I absolutely love President Obama, he's fantastic. And you'll get people say, you want to hear what I think about President Obama? You're going to get both ends of the spectrum. You're going to get people who love him, you're going to get people who hate him. But a lot of the people who are in the middle, like, yeah, I guess he's okay. A lot of those people are going to say, no, I don't have time for that. Because ain't nobody got time for that. The point is, if you do a voluntary response sample, you are always going to get people who have strong opinions, and that biases the data. You only get people who want to answer, and you're completely missing everybody who doesn't want to answer. That's what skews the data. You will always wind up with biased data because only the people who want to answer will. There's always that potential for bias. So we should avoid a voluntary response sample. And once again, a voluntary response sample, people get to choose whether or not to participate. Text message surveys, online internet surveys, phone call surveys, these are all methods where people have to volunteer to participate. Even if you give people a survey and say, hey, I want you to turn this in, and you tell them how to turn it in, the person can still choose to throw it in the garbage. That's still a volunteer. There's always a source of bias. You should avoid this if at all possible. A second bad sampling method is a convenience sample. The convenience samples are basically, you just ask whoever is available. One of the easiest ways that we could do a convenience sample is, well, Mrs. Steele's classroom is right next door. We can go ask her class. Well, that's not random. They're close to us, so it makes it easy for us to get the information, but that doesn't make it random. And we know random removes bias. Another one we could look at doing is say, well, let's just go ask everybody here on the floor. Let's go right next door to Mr. Tyler's room. Let's go across the hall to Ms. Reimer's room. Those aren't random. We're asking those people because they're close by and it's easy to do. Okay, so Alex asked the question, what if we said, let's go ask the guys in partial? To that I have to ask my own question. How did you pick partial? Was partial picked like name out of a hat with a random sample? Or did you just say, hey, I want to go ask partial? If you say, I want to just go ask partial, there's no randomness there. You have chosen them. If you say, I want to go ask Mandarin, that's not random. You're picking the people to volunteer, you're picking the people to survey. Well, that's not random. That's another instance of a convenient sample. Now you could look at it and say, well, why is it convenient to go ask partial? Well, it's a whole lot easier than asking Fargo. It's a whole lot easier than asking Bismarck. At least we don't have to drive a couple hundred miles to go. White Shield too. In a convenient sample, you just ask people who are easy to ask, or maybe they're conveniently located, like next door, like down the hall, like just down the road over in Partial. If they're easy to get to, and you're picking them because they're easy, that's a crappy one. You'll see these ones most commonly, like outside of Walmart. They can have pieces like, hey, do you want to answer this question? Do you want to do this survey right outside Walmart? Well, why did they pick the outside of Walmart? Because you've got a crap load of people walking in and out. And if you've got people walking in and out constantly, then you've got a lot of people that you can say, hey, do you want to do this quick survey? That's convenient to stand outside Walmart and do a survey. But it's going to be biased because if you stand outside Walmart, the only people you ask are the group who go to Walmart. What about all those people who say Walmart sucks and I'll never shop there?
What about
Then they have no chance of getting picked.
standing in the middle of the mall?
Standing in the middle of the mall is the same thing because there are people that say, I hate going to the mall, I won't shop there. And none of those people have a chance of getting asked. So it creates bias by leaving out groups who have no chance of getting selected. Emphasize again, convenience sample. You ask people who are easy to ask or perhaps close by.
My mom got from my shoulder.
Okay? Read the example and let's ask some questions about it. So in the problem, and we've got A, B, C, they're all different problems. We want to know what kind of sampling method it is, and is there any potential problem or bias? So let's start here. The first 2,500 fans to arrive are asked the 5-question survey. What kind of sampling is that? The first guess was a stratified sample. Stratified takes the population and splits them up into groups, like freshman, sophomore, junior, senior, and then randomly picks a sample from each group. That did not happen here. Is there anything here where we talk about splitting the population into groups? So it's not going to be stratified. What other options do we have? Is it simple random? Remember, simple random, you create just one long list and then randomly pick, names out of a hat style. This one is a convenience sample. The first 2,500 people to show up get asked. Well, it's pretty easy just to say, hey, you're walking through the door, here's your survey. Oh, you're walking through the door, here's your survey. It's easy to do it that way, which makes it convenience. Well, what type of bias, what type of problem exists when we ask only the first people to show up? And what do all those people have in common?
They show up first.
Exactly, Keenan. They show up early. So you don't get people who come to the game late. You only get the people who want to watch batting practice. You get only the people who really, really love baseball and want to get there hours early. So
People get that hours.
You're invited. You're invited. They're gonna be slammed by the time the song starts.
okay, so pretty informal way of writing that up. It's a convenient sample and a potential source of bias or a potential problem for sampling only the early birds, the people who show up really early. Let's switch colors and look at question B. Read through it. And what do you think? What type of sample is that? The first guess was a multi-stage in class. Absolutely correct. Remember, a multi-stage, you do stage after stage after stage of random selections. First, we randomly selected a section. Then we randomly selected a row. Then we randomly selected chairs. We had stage, followed by stage, followed by stage. This is an obvious one with doing a multi-stage random sample, which is a good sampling method. But still, what's a potential problem? Absolutely, Chance. What if a seat is empty? You know, maybe the person's at the bathroom, or maybe they're going to get some nachos. Maybe they just didn't, maybe they're sick and they didn't go to the game that day. Maybe they're late. We don't know, but what if an empty seat is picked? In this particular scenario, since an empty seat is a problem, before you do any kind of sample, before you start picking the sections, you have to have an answer to this. If you pick a randomly selected seat and it's empty, what are you going to do about it? If you're actually designing the experiment, you need to answer that ahead of time. Let's go on to question C. Take a second to read it. And what sampling method do you have? All right, some of the ideas that students threw out in class. A simple random sample because there's one huge list and you're picking from the list. Another one that was floated out was they thought it was a systematic because you're taking and following some type of a rule. Well, we need a rule for a system saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, where we pick every third person or something like that. They don't describe a rule here, so it's not systematic. A thought was also a cluster sample. A cluster sample splits the entire population up into representative groups, groups that contain a little bit of everybody, and then one of those groups is randomly selected, and you do a census on the group. This one's not a cluster because we're not splitting people up into those random, representative groups. This one is actually stratified because we have a group of people who come to the game and people who don't go to the game. What we did here, because they did a sample only of seats that were occupied, because they were picking only the group that was occupied, the only ones that have a chance of getting picked are there. That looks to me like a strata. There is also a very strong argument here. Nathan, you mentioned that this would be a simple random. There's a very strong case for this to be a simple random sample, because basically what you've done is throw out. We had this question of what do you do if you have an empty seat? Well, right away at the beginning, they've used the computer to throw out all the empty seats. They're using only the filled seats. So you could make a very strong case that this is simple random. You could make a case that it's stratified. The most important thing, can you justify your reasoning? If you can justify why you think it is a particular thing, and you can explain how it fits stratified, how it fits simple random, if you can explain why it fits a particular sampling method, that's what we care about more than anything. Being able to think and being able to process is far more important than just saying, well, this is the answer. Let's go on to question D. Go ahead and read it. What type is it? first guess out there was a volunteer sample? Absolutely. People have to say, sure, I'll fill the survey out. You can give them directions on how to turn it in. But if they choose to just throw it in the garbage, what do you do then? You'll also notice that's definitely a potential problem. We want 2,500 people to answer. What do you do if people don't answer? That's one potential problem. People not participating is one potential problem you need to encounter. You need to have a solution for it. Let's go on to question E. Take a moment, read it. What kind of sample is it? The first guess in class was systematic. Absolutely. This is definitely a systematic sample. Because we randomly select the first person. That was randomly selected. After that, we're following a rule. Every 12th person. Absolutely systematic. So what's a potential problem there?
What if it's
Okay. Besides some of the funny jokes that were going around with it, like what if it's a baby, what if it's a zombie, what if, they're on a holy vow of silence. One of the things that came up that was a good point, what if the person is deaf? What if the person doesn't speak English? What if they're blind?
if he's black?
It's possible. One of the questions is, well, why would they be going to a baseball game if they're blind? Well, because maybe they're just spending time with their family and they want to go spend time with their family to go watch.
They can't see.
That doesn't matter. You can still hear. They have announcers who describe what's going on.
You can't see your family.
So the point that you would want to have, one potential problem that we would want to have a plan for.
So you do some good seeds.
And we'll have to note, this is a potential issue with every single survey. What if there are special circumstances, like the person doesn't speak the language, they're blind, or deaf? What if they don't understand the question? You have to have a plan in place to handle special circumstances. Okay, let's move on to F. Take a moment to read F. What type of sampling is this? The first guess in class is that this is a cluster sample. And I have to make the point. In a cluster sample, you split the people up into the groups, into the clusters, and then you randomly select one cluster and do a census on that group. That didn't happen here. We split people up into groups, but then we're randomly selecting a sample from each of the different groups. That's not cluster sampling. When you select a little bit from each of the groups, that's stratified. A stratified random sample splits people up, and they don't have to be equal representative groups. You just split them up into some type of a group, and then sample from each one. What potential problem could occur here? Besides some of the common ones that, once again, we could run into a special circumstance, person being blind. We could have the seat be empty. We have all those same issues that we were mentioning before. Are there any specific to this one, though?
No.
Get that, like, it's not bad.
Okay, so we're not seeing anything, and we finished up here. Let's move on. We were talking that a convenience sample and a volunteer sample are bad methods of collecting data. Well, those are not the only things that can go wrong. Collecting data in the wrong way That's an example of a bad sampling method. Although they get used frequently, a bad sampling method is a mistake. Other mistakes that you can do have too small of a sample. Let's say we want to do a survey of NBA players. We want to predict how much money NBA players will make in their career. And so we asked LeBron James, we asked Kevin Durant, and we asked Kobe Bryant.
Yeah, it's unfair.
Hooray! We've asked 3 people, and they've told us, well, I've earned $180 million, I've earned $300 million, I've earned $200 million. And so looking at those 3 guys, we're not going to say, oh, cool, 200 million, 180 million, 300 million. The average NBA player earns about $250 million in their career.
That's not right, though.
And absolutely, that's not right.
There's a couple that didn't finish their career.
Because, well, besides the fact that you have people who haven't finished their career yet, well, even if we were to go back and say, well, let's ask only players who retired recently. So we can ask Jordan, we could ask Hakeem Olajuwon, we could ask Charles Barkley.
Samson.
Shaq. The point is, if you only ask 3 people, do you think 3 people are going to be representative?
No, because some can be key players and some could be.
You got your stars?
Depending on who gets picked, if you're picking only 3 guys, the chances are you're going to get Joe Schmuck, who sat on the bench, Christian Leitner, and I don't know, Jason Terry, Brian Scalabrine. If you're going to pick guys who are in the NBA, most likely, just because of probability, you're going to get guys who are in the league 1 or 2 years. You're probably not going to randomly select Michael Jordan. You're probably not going to randomly select LeBron, because LeBron is 1 player out of 400 currently in the NBA. We would still have to factor in the 1,000 guys who washed out and didn't make it, and all those guys that are in the D League. You really think that you're going to randomly select LeBron when he's 1 out of 2,000 players in the list?
Yeah.
Probably not. Yeah, even selecting any All-Star, you might have, what, 50 All-Stars out of a list of 2,000? That gives you less than a 3% chance of picking somebody who's good. Most of those guys are going to be the schmuck who was in the league for 1 year and washed out.
Why you gotta hit me with one?
So, if you don't pick enough people, you're not going to get an accurate representation. If there are 2,000 people to look at, how many do you think you should look at? 100 people? Maybe 200? 50? Well, you would have to come up, you would have to pick that number ahead of time. You probably don't want to do 1,800 because you don't need 90% to get a pretty good idea of what's going on, but picking 10 people out of 2,000, it's just not enough. If you don't get enough people, you're going to run into problems with bias or just dumb luck, weird things happen.
Picking 1,000 out of 2,000.
1,000 out of 2,000, doing half, that would be fantastic. If you're getting half the people, it would be absolutely wonderful to get that many.
Here's my second.
Okay? Another common mistake is under coverage. Under coverage is when one group is completely left out. Here's a good example. Let's say the students at Ray are going to do a survey during 7th period today. Why is it wrong for the students at Ray to do 7th period survey today?
Because they got a game today.
Exactly, Alex. Because the girls' basketball team has an away game, they're not going to be there. Because the girls' basketball team in Ray would have no chance of getting selected, there's nobody who would get picked from there. They don't even have a chance to be picked. That is under coverage. If a group has no chance of getting picked, it's a problem. You will frequently run into, when we want to do surveys up here in the school, we will frequently run into problems with that. If the boys basketball team is gone, we're going to have an undercoverage error because we can't ask them anything. If the wrestling team is gone, if the girls basketball team is gone, we will have undercoverage errors because they don't get even the chance of getting selected. It's a problem. You should absolutely avoid it if at all possible. Another type of error that will happen is a random sampling error. We know just from probability that once in a while weird things happen. I mean, it's possible you could flip a coin 10 times and have it come up heads every single time. That's going to be rare. Once in a while, you just get some weird, fluky, just you look at it and say, how in the world did that happen? Just because of dumb luck? That might happen. And there's really nothing you can do to control, oh my God, dumb luck screwed me over here. It might wind up happening. When that type of thing happens, it's a random sampling error. There's nothing you can do to avoid it. Sometimes weird stuff happens. This is the big reason why scientists always demand repetition. You do an experiment and you get your results. One time is not good enough. You have to do the experiment again and again and again. You do the experiment over and over and over to see, do you get the same results? Because everybody knows you might have only a 1 in 1,000 chance of getting that weird fluke. But if that weird fluke does happen, you wind up looking at something and say, oh my God, it turns out that if people eat lead for breakfast, they're going to live a long and healthy life. And in reality, lead would kill you. You have to be able to repeat the experiment. Earlier, when we were discussing the volunteer sample, we said, well, what are you going to do if people don't answer? If they just throw your survey away? That is another source of bias. It's non-response bias. One of the reasons why surveys or using volunteer sampling is bad, because it's guaranteed to have non-response bias. Anybody who doesn't want to participate won't. And that is itself biased. You're getting information only from the people who want to participate, who are actively saying, please call on me. Well, that type of bias is called a non-response error or a non-response bias. Here are two examples to look at. And this is important enough that I do want to read the questions. Think about the way these questions are phrased. Do you believe it is reasonable for the government to impose some limits on purchases of certain types of weapons in an effort to reduce gun violence in urban areas? Okay, what do you think about the way that question is phrased? Now consider this. Do you believe that it is reasonable for the government to infringe on an individual's constitutional right to bear arms?
No,
Are those questions asking the same thing?
sir.
Well, I can tell you this part right here, and this is my own personal opinion. If you have an opinion different than mine, that's fine. This is just the way I think. To me, I would look at this and say, yes, it is reasonable to put some limits. For instance, I don't think too many people need to go buy grenade launchers. I don't think grenade launchers are really covered under the Second Amendment. Now, if you look at it and say, you're not allowed to own a shotgun to go hunting, or you're not allowed to go own a rifle to go deer hunting, I've got a problem with that. My answer, for me, would change depending on how this question is phrased. You phrase the question here for the first one, I'm going to say yes. There should be some limits. You phrase it of, do you think it's right for the government to violate the Constitution? My answer is going to be no. Well, this type of leading question is a source of bias itself. If you phrase questions in such a way that you're leading people toward the answer you want, that's bias. Whenever you ask a question, it needs to be neutral. Wording of a question is another source of potential error, another type of bias. If the researcher is already trying to manipulate the results of the survey, they're biasing the questions themselves to get what they want. But it's not just the researcher who can have a bias. Response bias occurs when the individuals lie. For instance, let's say we're asking Victoria's Secret models how much they weigh. Do you think all those Victoria's Secret models are going to tell you the truth about how much they actually weigh?
Nope.
No.
Let's say you look at it and you're in a clinic doing research on diabetes and you ask people, how many candy bars have you eaten in the last month? Do you think people are going to tell you the truth?
If they remember.
Well, if a person has diabetes, they should try to avoid, they know that I'm not supposed to have any candy. For certain types of diabetes, you're not supposed to have any candy at all. And so they may lie and say, oh yeah, I didn't have any. And a really good example, if you are on the an organ transplant list, an organ, like a heart, lung, kidney, organ. No, I wasn't trying to say Oregon, the state. Organ transplant list. One of the rules on an organ transplant list, 0 alcohol. If you have 1 beer, you are removed from the list. Permanently. You have 1 beer, if they find out about it, you're taken off the list, you will never get the organ you need, you will die. Do you think people are going to, if they're actually out drinking, do you think they're going to be honest and say, oh yeah, I had 5 beers last week?
No.
No, they know the correct answer has to be 0 or I lose the organ. They are going to lie in that situation. The same way that a Victoria's Secret model could lie about their weight. People lying is bias. And you really can't control people from lying, but you should be aware of it. In a particular situation where people have a strong motivation to lie, you need to be aware of it and kind of look out for it. One of the parts that I think is really funny, Netflix.
Oh, the potato chips, huh?
If you ask people, and Netflix has actually done this type of survey, if you ask people what they watch on Netflix, a lot of people say, I watch documentaries. I really like the History Channel shows on Netflix. To the point that, and I don't know the numbers, so I'm making them up right now, but maybe 30% of people say they have Netflix to watch the History Channel, like the life documentaries. But when Netflix actually looks at their numbers, it's like 10%. It's way lower than this actual what people say. A lot of people will say they watch documentaries because it makes them sound smart. And in reality, they're just out there Netflixing for other purposes. One type of, another type of mistake that can happen, just a human error. You collect the data and you have to type it in to the computer. What if you screw up when you're typing?
Boot it off.
I actually had something like that happen earlier today. I intended to type the number 20, but I didn't type the 0, and I actually typed down the number 2. Well, 2 versus 20 is a big deal, and just because I accidentally typed the wrong number, I got some screwed up results. Well, what ended up happening is I looked at it and said, I had to go back and find the mistake, and then I corrected it and then just redid the work. That's something you've got to be careful about. Human errors is a type of mistake that can happen. And I want to end today with just this last piece. I really like this part. If a reported statistic doesn't seem right, go check the calculations. Because if something seems too good to be true, it actually might be. Check your numbers to make sure things actually are right.